And here is a proof that the square root of 5 is irrational, in which we'll be using an even-odd contradiction. We start with the supposition that p upon q equals root 5, where p and q are members of the integers and their greatest common divisor is 1. So that p equals root 5q, and if we square both sides, that implies that p squared is equal to 5q squared. Now, if that statement is true, and if the greatest common divisor of p and q is 1, then p squared and q squared cannot both be even. And we can't have one of them even and the other one odd, because that would imply that we were stating here there's an even integer is equal to an odd one. So they must both be odd. So we're now going to give them both the form of odd numbers. So we represent p as 2r plus 1 and q as 2s plus 1, where r and s are members of the integers. And so the statement p squared equals 5q squared becomes the statement 2r plus 1 squared equals 5 times 2s plus 1 squared. And we now proceed to multiply these out, so that we can now see that the left-hand side is 4r squared plus 4r plus 1, and that is equal to 5 lots of 4s squared plus 4s plus 1. And I now multiply out the right-hand side to get 20s squared plus 20s plus 1. And so we had 4r squared plus 4r plus 1 is 20s squared plus 20s plus 5. I take 1 off each side, and I get 4r squared plus 4r equals 20s squared plus 20s plus 4. I factor out the 4 on each side to get 4r lots of r plus 1 is 4 lots of 5s squared plus 5s plus 1. I now divide both sides by 4, and I get r times r plus 1 is 5s squared plus 5s plus 1. And if we look at the left-hand side, I've got r times r plus 1, and that is two consecutive integers multiplied by each other, one of which must be odd and one of which must be even. And so the left-hand side is an even number. And so now I have factored out the 5s on the right-hand side, and I've got 5 lots of s times s plus 1 on the right-hand side. And s times s plus 1 is an even number in the same way that r times r plus 1 is an even number. And so 5s times s plus 1 must be even. And so what I have got here is this on the left-hand side is an even number. Beg your pardon. On the left-hand side, I have an even number. And on the right-hand side, I have an even number. The idea that the square root of 5 is rational implies that an even number should be equal to an odd one. And so we prove by the use of an even-odd contradiction that the square root of 5 is irrational.